Hey, statistics students, what we're going to do is I'm going to just give you a whole bunch of definitions that you need to get down, give you a little bit of background explanation for it. So please write that down. And then in class, what I will do is I will show you how to do a completely randomized design, block design, and a match pairs design. So I'll fly through some things. Again, they're all mainly definitions and then background or explanations behind those definitions. First one is an observational study. Some of you, I think one of my blocks have already written this down. An observational study observes individuals and measures variables of interest, but it does not attempt to influence their response. So, for example, if I want to know what percentage of people at Armstrong drove an SUV, I could just go out to the parking lot and count all of the cars and then the number of SUVs and find that percentage, right? And draw conclusions that way. That's an observational study. Anytime you're given a sample survey and asked to check boxes, that's an observational study. Is it disrupting your life? Yes, but it's not attempting to influence any response. It's just, or it shouldn't be, obviously. It's just getting your opinions about things, observing your opinions. Now, an experiment is different. An experiment deliberately imposes treatments on individuals to measure their responses, okay? This would be something where, let's say I wanted to see how well does sleep affect your mood, okay? So I could say, hey, I'm gonna take you guys for a sleep study. I'm gonna split you into 3 groups. One group, I'm gonna say, you get 4 hours of sleep a night. The other group, you take 6 hours of sleep a night, and the other group, you get 8 hours of sleep a night. So I am imposing a treatment on you. That treatment is how much sleep you'll get. Then what I'll do is I will respond, I will look at the response, and that is I will rate your mood, and I'll rate it on a scale of 1 to 10, okay? That's an experiment. Lots of different experiments out there. I have talked about lurking variables and confounding before, so I'll quickly skim over this. A lurking variable is a variable that is not among the explanatory or response variable in a study, but may influence that response variable. So it's something that is influencing that response. So we have this explanatory variable here, and then we have the response variable, okay? We're looking at this online versus classroom experience, okay? Does that influence test scores? Okay, so this was pre-pandemic, obviously. They would look at maybe a math teacher who taught one group online and another group in person, and then they'd look at test scores and compare. But there are different lurking variables, different things that might affect this response that we're not measuring, such as student preparation, or maybe time of day may influence that as well. General intelligence. How about how much you had to eat that day? So there are things that may influence this test score that we are not measuring over here. What makes something confounding, though, is when you can't tell the difference, right? So it occurs when 2 variables are associated in such a way that their effects on the response variable cannot be distinguished on each other, okay? Now, let's think about this idea of sleep and mood again. Is sleep affecting mood? Or could it be something like food? I know some people in my family, not all, but some people in my family, when they haven't eaten, okay, or they haven't eaten very well, the food they have eaten or not eaten at all will affect their mood as well. So now is it that they didn't get much sleep at night, or is it that they didn't eat well, or they didn't eat at all? If it can't be distinguished, it's called confounding. Now, the College Board is going to be specific on what they're looking for when you're talking about a confounding variable. So I want to talk about that right now. Hold on, there's a lot here, so give me a second. I don't want to overwhelm you. When you're identifying a possible confounding variable, so you need to explain 2 things. How it's associated with the explanatory variable, and then also how it affects the response. So a confounding variable should be associated with that explanatory variable as well, okay? What is the explanatory variable? We talked about this, you guys, in our linear regression unit. The explanatory variable is what is influencing the response, okay? And we'll rewrite those definitions down again if we need to. So let's talk about the sleep and the mood, okay? I said that food could also influence mood. And now if we don't know if our mood is because of how much we slept or how much food we ate, we call that confounding, okay? So people who sleep more probably care about being healthy. As a result, they eat healthier. What I've done right there is number 1, I've associated that that confounding variable with sleep. Okay, so it was a lot of times says, well, what's the difference between a lurking and a confounding? It becomes a confounding variable, A, when it's tied to this explanatory variable, and B, when I can't tell the difference if it was sleep that affected the mood or was it food that affected the mood, okay? That's when it becomes confounding. Now, we tie it to there and we say, okay, so people who sleep more probably care about being healthy. As a result, they probably eat healthier, okay? So I've just connected food to sleep. Now we have to talk about, hey, we don't know if the mood is because of how much they slept or because of what they ate, okay? So are they happy, or is the mood a certain way because they slept a lot or because they had good eating habits, okay? Again, number 2, how it affects the response variable. Are they happy because they slept a lot or because of their eating habits? We can't tell the difference with that response variable. Which one was it? Okay, pause, rewind, take a quick little break. I'm going fast through these definitions, so hopefully you are pausing and writing things down when you need. We are going to go through this caffeine one in class, okay, and practice that terminology. Okay, so I'll leave it up here in case you weren't in class, but we're going to read through this one together in class. I'm going to put a little star by it. Give me one second. Let's put a little heart. These are the ones we're going to do in class, okay? So I'll do that with you guys in class. But what I do have is just the idea of what an explanatory variable is and a response variable is. We did talk about that in our previous unit, but write it down just so you have it down again if you didn't write it down in the previous unit. Okay, let's move on. One thing you need to know about observational studies and experiments is observational studies of the effect of one variable on the other often fail because of confounding between the explanatory variable and one or more lurking variables. Well-designed experiments take steps to prevent confounding, okay? It's called control. The moral of the story is beware of the lurking variable. Always beware of that lurking variable, okay? It could cause confounding. When we're talking about an experimental design, okay, one thing with the explanatory variable is when we're talking about an experiment is a way that we can establish cause and effect, okay? And another kind of word for explanatory variable is called a factor. So we talk a lot about factors. It's the cause. Now, one thing you want to do is you want to decide, you need to be able to identify in an experiment, okay, with the explanatory variable, how many levels there are. So let's go back to that whole idea of if I'm going to do a sleep experiment on you guys and I say, hey, let's get 4, 6, 8 hours of sleep, or 2, 4, 6, whatever you want to talk about. That would be how many levels I have right there. Okay, so if my sleep is my explanatory variable and I say, hey, one group's getting 4 hours of sleep, one group's getting 6 hours of sleep, and one group is getting 8 hours of sleep, those are my different treatments I'm imposing on you. Okay, so sleep is my explanatory variable. I have 3 levels here, okay? It's important that you're able to identify how many levels your factor or your explanatory variable has, okay? Your factor, your explanatory variable has. Again, your response variable then is that effect. So what is being influenced, that mood. Okay, sorry, I got a phone call. So what I was saying is that response variable is that effect, or that response variable is the variable that we're measuring the outcome of, okay? We're seeing that explanatory variable is going to influence an outcome. Now, again, we don't use the word cause and effect. That's why I have them in quotes. Really in statistics much, unless we're talking about a well-designed experiment. We talk about it in terms of an explanatory variable or a factor and a response variable. I just personally think it's easy for students to relate to the term cause and effect. It's a nice way to tie it into some previous knowledge of yours. Okay, let's get the definition of a treatment down. Okay, so a treatment is a little bit more complicated than it just sounds. Okay, so a treatment is a condition applied to the individuals in the experiment. It determines how many groups you need in an experiment. So let's go back to this whole idea of this sleep study, right? Or this sleep experiment. Right now, my factor is I'm looking at sleep and I'm seeing how it influences, right, people's mood. Now, there are 3 levels to this factor or this explanatory variable because I'm looking at 3 different things. That means I need 3 treatment groups. I need 1 group, right? That's my treatment. 4, 6, and 8. That's my treatment there. I need a group for the 4 hours. I need a group for the 6 hours, and I need a group for an 8 hours. But here's the catch. Okay, so if I have 1 factor, your treatments, how many treatment groups you need is just the levels of the factor, like what I just said. But what if I have 2 or more factors? What if I decided that, hey, I know that food can also be confounding with sleep. So I'm going to control that. I'm actually going to tell you guys that, hey, I'm going to have a group for 4, 6, and 8 hours of sleep, but then I'm also going to control what you're eating within that, okay? So now I'm going to say, hey, I'm going to have you do a group of 4 hours who ate breakfast and a group of 4 hours who didn't eat breakfast. A group who sleeps 6 hours who ate breakfast and a group who slept 6 hours and didn't eat breakfast. And then finally, a group who slept 8 hours, ate breakfast, and a group who slept 8 hours and did not eat breakfast. So I'm throwing another factor in here. I'm now investigating how sleep and eating breakfast or not influences mood. So I have 2 factors here. How many treatment groups do I need? A combination of the levels for each factor. So the sleep, the sleep has 3 levels. And the breakfast or not, how much we've eaten, that has 2 levels, breakfast or not. Together, a combination, when we did combinations, when you were in squeeze or pre-calc or whatever, that means multiply. I multiply that together. 3 times 2 means I'm going to need 6 treatment groups. And I was explaining that as I went on. Hey, I have 4 hours of sleep and breakfast, 4 hours of sleep and no breakfast, 6 hours of sleep and breakfast, 6 hours of sleep and no breakfast, 8 hours of sleep and breakfast, 8 hours of sleep and no breakfast. Okay, 6 groups there, 6 treatment groups. All right, let's move on. If someone's talking about an experimental unit, that is who is being tested. Okay, the singular. So the experimental unit for our class would be each student, right? Singular. You are an experimental unit, you are a student. Now, technically, if that experimental unit is a human, we actually don't call them units, we call them subjects. Let's keep moving on with the definitions. There are 4 principles of experimental design. And remember, experimental design is the only way to establish or understand cause and effect. We cannot do it through an observational study. Please write these down. Number 1, control. We want to control the effects of lurking variables. Control groups also give us a baseline for comparing, okay, for comparison. Number 2, random assignment. I'm not going to just let you choose which group you want to be in. Do you want to sleep 4 hours, 6 hours, or 8 hours? Okay. I'm going to randomly assign you to a group. And the reason I do that is I want all of my groups to be equivalent, meaning kind of the makeup is the same. Each group is very similar in the makeup. This is so we can attribute the response results to the treatment and not to lurking variables. An example of this would be, hey, what if I was trying to do a reducing stress activity at school and I wanted to see if different activities reduce stress, right? So I say, hey, there's a yoga group, there's a video games group, and there's a shoot and hoops group, and you can do it right after lunch. And well, let's see if that reduces stress of high school students. Well, oftentimes high school students like to do what their friends want to do, right? So you check with your friends. What are you going to do? Oh, I'm going to go do yoga. I guess I'll do yoga too. Even though I wanted to shoot hoops, I'm going to go do yoga too. Now, we measure people's stress because they got to choose after. Is there stress reduction or elevation because of the group they were in? Or is it because they chose to be with certain people and that either reduced their stress or elevated it? Okay, so that's why we want to randomly assign people to groups. We want those groups to be equivalent so we can attribute that response to the treatment and not to any lurking variables. Number 3, replication means we want to use enough subject. Okay, the more subjects we have, the less variation. This is important. This again helps us ensure that the differences in response is due to the treatments and not just chance variation. You think of flipping a coin, okay? I'm going to talk about that. But if we think about in class together, but if we think about flipping a coin, if I flip a coin 10 times, is it plausible that 8 of those times I could flip heads? Yes. Okay. But if I flip it 100 times and now 80 of those times are heads, something's going on. What should happen if I flip it 100 times, it should be really close to the actual truth about a coin. Okay. It should be, will it be exactly 50? No, but it could be about 49, maybe 51. My point is there is less variation when we increase the sample size. Again, 10 times there's going to be more variation. Maybe I'll flip it 8 of those times I'll flip heads. Maybe 2 of those times I'll flip heads. That's just, chance variation. But as I increase that sample size, it's going to waver more around what that should be, and that's about 50%. And then finally, blocking and blinding if possible. I'm going to teach you how to block, but I want to talk about what blinding is. Let's do that right now. A double-blind experiment is an experiment where neither the subject nor those who interact with them and measure the response variable know which treatment is a subject's received. If I'm doing a study on anxiety and I have a placebo pill, which is a fake pill, and then I have another pill, pill A, which is a certain drug, as the researcher, or as the person giving the treatment, I'll give you pill A, I'll give you pill B, A, B. I don't know which one's the placebo, and I don't know which one is the actual treatment. You don't either. I record the responses, then I give them to the actual researcher who's running the data. That person knows. A single blind would be if I was giving the treatment, I know that pill A is the placebo and pill B is the actual drug, but you don't know. That's a single blind. So just the subject doesn't know. If the researcher finds statistically significant results, that is an observed effect so large that it would rarely occur by chance. That's that whole idea. If I flipped a coin 100 times and 90 of the times, it flipped heads, that's significant. Something is wrong with that coin. That is so different than what should have happened that something is wrong with that coin. We have statistically significant results. But if I flip a coin 100 times and 48 of those times were flipped heads, that's not so much statistically significant. It's only 2 away from what should have happened. Another example would be, let me give you a second, would be, let's say I did I did an experiment. I had a bunch of people, right? And I did an experiment about Advil versus Tylenol. And I had people measure their headache pain after, 3 weeks. And people with Advil, they rated it on a scale of 1 to 10 as a 3. And Tylenol rated their headache pain on a scale of 1 to 10 as a 4. That observed difference between the two, that's not very big. What would it take to convince you that we had statistically significant results? I'd say, what if this was like an 8? Wow, then I'd say, wow, Advil really is better than Tylenol. That observed difference is so large, it probably didn't happen by chance. Now, the cool thing about statistics is there is a tool, a mathematical way that we can measure if something is statistically significant. And that's what we spend the whole second semester on. And it's really quite cool. And I think for those of you who really love math, you will like that. Just a little FYI. For now, all you need to know is just the definition and how to apply that to a problem. And again, if you just use this definition right there, observed effect, if you talk about what that effect is in context, you will be A-okay. Random assignment, another definition here that you need to know. How units are assigned to treatments at random. And we talked about how to use a table as a way to randomize, as well as the hat method. You can also use a calculator. A completely randomized design. The treatments are assigned to all the experimental units completely by chance, You are going to have to know how to design a completely randomized experiment. And I'm going to do that with you in class together live. Okay. I just want you to, again, the purpose of this is just to get some definitions down. So that frees up our time in class to go through questions and do some investigations. Let's move on to the definition of a block design. You know what? I'm going to actually have you do that together in person. So we're going to be done for the day. The rest of it we'll do in person together, and I can clear up any questions, clarify anything for you if you need. So I hope everyone's having a great day, and sorry I'm getting this video out so late. But again, just definitions. So if you don't get it done by tomorrow, you'll be okay.